Hey students, Mr. Danahauer here. I wanted to just do a quick recap of limiting an excess reactant because I know that it can be a confusing topic for everybody. And so real quick, what is a limiting an excess reactant? The idea with this whole concept is that when we have reactants, we're going to ultimately run out of some or all of the reactants in a reaction. As the chemical reaction is taking place, we're limited on what we have. And so we're going to run out at some point. Now, in our limiting reactant problems that we see in class, typically you're given amounts of all of the reactants that are involved, which is normally 2 reactants. And so you have 2 reactants, and at some point, one of those reactants is going to get all used up. So that one that gets used up in the reaction, that is our limiting reactant. So there's 2 ways to look at a limiting reactant. The limiting reactant is either the one that gets used up first in the reaction, so the reactant that we run out of first, or another way to look at it is it's the reactant that makes the least amount of product. And that makes sense, right? Because if we have 2 reactants and we're making product, and then all of a sudden we run out of one of the reactants, that reactant that we ran out of is the one that limited us to the least amount of product. So those are 2 ways to look at what a limiting reactant is. Now, the substance that we don't run out of is the excess reactant. And so I've labeled those LR and ER. Limiting reactant is the one that we run out of or limits us to the least amount of product. Excess reactant is the one that we have left over in the reaction. So I want to run through a couple of problems. One of the hard things about limiting and excess reactant problems is there's a whole lot going on. You guys are probably pretty comfortable with doing the stoichiometry. Okay, we're going to convert from one reactant to the product and see how much product we make. And that's pretty straightforward, right? Even though that seemed complicated a while ago, we've got that down. But when we have to start doing multiple stoichiometry problems and comparing numbers, that gets a little more complicated. And so let's walk through a couple of examples here. And for this first reaction, I have solid calcium is going to react with oxygen gas to create or produce calcium oxide. So remember, anytime we're doing stoichiometry, what do we need? We need a balanced reaction. We have to have the coefficients so that we know what proportions the reactants and products will combine together or create. We have to know the proportions of everything. It's sort of equivalent to a recipe. So let's go ahead and balance this really quick. I'm going to put all the coefficients in just so we have those. Okay. And one here. So I know 2 moles of calcium will react with 1 mole of oxygen gas and produce 2 moles of CaO, calcium oxide. Now, let me put some numbers on here to get us started. So let's just pretend like we have 4 moles of calcium, okay, and that we have 3 moles of oxygen gas. Now, I'm starting with moles here. Normally, we have grams or of reactants, or we have liters of gases at STP, all of this stuff. But you guys know how to get to moles from those things. And so if you can understand how to go from moles to moles, then going from grams to moles or moles to grams is just one extra step in all of that. So if we can, we want to just understand it simply put here. But we're going to start with moles and end with moles, and we're just going to go use that as our first example here. Now, there's multiple ways that you can figure out limiting reactant. And I know this is a limiting reactant problem because I have set amounts of my reactants. The calcium, I have 4 moles only and 3 moles of the oxygen gas. So I know in this reaction, I'm going to run out of one of these reactants. That will be the limiting reactant. So 2 ways to figure out which one is the limiting reactant. Let's go ahead and start with my first method, which is the one that most people feel comfortable with. Like I said, the limiting reactant is the one that we're going to run out of first. It's the one that we are going to make the least amount of product. So if we can go ahead and take each reactant and figure out how much product is made, then we can compare those amounts and say which one makes the least amount of product. So let's go ahead and do that process first. And I'm going to start, but basically here's what I'm going to do. I'm going to go from 4 moles and I'm going to figure out how many moles of calcium oxide I can make from my 4 moles of calcium. And I'm going to go from 3 moles and I'm going to figure out how many moles of the calcium oxide I can make from the 3 moles of oxygen gas. Right? We're going to do 2 different problems. We'll compare those numbers, and whichever one makes the least amount is our limiting reactant, right? Okay, so let's go ahead and start real quick. So we have 4 moles of calcium. Okay, oops, I don't know why I put an L there. 4 moles of calcium, and we're just going to go straight to moles. We have to get to product in this example of one way to figure out the limiting reactant. We have to go all the way to product. And so how do we do that? We use the mole ratio. And we know it's a 2 to 2 ratio. So 2 moles of calcium will produce 2 moles of calcium oxide, right? So pretty simple mole ratio problem going from calcium to calcium oxide. I know in this rate, this will reduce down to 1 to 1, of course, so we can reduce that fraction. So from 2 moles of calcium, I'll produce 2 moles of calcium. So 4 moles of calcium is going to produce 4 moles of CaI. So let me write that down, 4 moles. All right, now let's do the same thing with the oxygen and see how much calcium oxide we can make from the oxygen gas. So go a little spot here, 3 moles of O2. Now don't forget, we have O2 here. It's not just 1 oxygen, it's 2. And so we need to make sure that we, actually it doesn't matter because we're not dealing with a molar mass anyway. I was thinking we were doing molar masses. Okay, so now let's use the mole ratio. It's a 1 to 2 ratio. So 1 mole of oxygen will produce 2 moles of calcium oxide. So 3 times 2 is 6. And so we get 6 moles here. Okay, so now we figured out how much product each of the reactants can make. We know that the least amount of product is made from the orange here, the calcium, right? So in this problem, because I can only make 4 moles of product with the calcium, and I can make more than that, 6 moles with the calcium oxide or with the oxygen, I know that the calcium is my limiting reactant. So this is my limiting reactant. Okay, that's one way. We take each reactant and we go to moles of product. You can also go to grams of product or liters of product. The key is we have to end with the same units. If you look at my units here, both of these are moles of calcium oxide. Okay, moles of calcium oxide, moles of calcium oxide. Now I can compare. I know that the calcium, the reactant calcium, makes the least amount of product. So that's my limiting reactant. So that's one way. Now, there's another way to figure out which one is the limiting reactant. There's actually several ways. And so I'm going to get rid of this stuff. And let's see another way that we can figure this out. In this method, instead of figuring out how much product I can make, I'm just going to go ahead and see how much reactant is needed to react with the other reactant. So for example, if I have 4 moles of calcium, how much oxygen do I need to react with that much calcium? So I can take this, basically I'm going to take this number and I'm going to go to moles of O2 here. Okay, I'm wondering how many moles of O2 would I use with 4 moles of calcium? Forget about the 3 moles. Okay, so I'm not going to put an X because I can't erase it, but forget about this 3 moles right now. We're just saying if I have 4 moles of calcium, how much oxygen do I need to react with that? So again, we're going to take this and we're going to do stoic 4 moles of calcium, and we're going to use that mole ratio, it's 2 to 1. I know 2 moles of calcium reacts with 1 mole of O2, oxygen gas. Okay. So how many moles of this gives us 2 moles of O2. So I know from that quick equation, from that quick calculation, I need 2 moles of the oxygen to react with 4 moles of the calcium. Now, if I compare that number to what I actually have, okay, I need 2 moles to react with the calcium, but I have more than that. I have 3 moles. That tells me, again, that calcium here is my limiting reactant because I have more oxygen than I need to react with the calcium that I have. Now, that is enough. That's all we need to do to figure out the limiting reactant. But let's say we went the other direction here. So what if I started with 3 moles of oxygen gas and I say, okay, if I have, I'm going to go this way. How many moles? Okay, 3 moles of oxygen gas, right? And I'm going to use the mole ratio is 1 to 2. So 1 mole of O2 reacts with 2 moles of calcium. And I get 6 moles. So I get 6 here. So what this is saying is if I want to react my 3 moles of oxygen gas here, I need 6 moles of calcium. How much do I have though? I only have 4 moles. So I know that I don't have enough calcium to react with all the oxygen. Again, this shows me that this is my limiting reactant. Calcium is my limiting reactant here. Okay. So both of those methods, the first one I started with, where we take each of the reactants and go to product, that can tell us the limiting reactant. Or we can pick one of the reactants and go to the other reactant and see how much do we have and how much would we need to react with it. That can tell us our limiting reactant as well. Now, this is a simple example of how we determine limiting reactant. But most of the time, what we really want to do is figure out how much product are we going to make in this reaction based on the reactants that I have, right? So that's a little bit more complicated. So we're going to come over here to this reaction, okay? And so let's go ahead and get some numbers on here. Let's say that I'm starting, let's see what I use. I'll use my orange and my green again. So let's just say that I have 75 grams of sodium to start with. And I have, let's do 95 grams of calcium nitrate here. And in this problem, I want to know how much calcium is going to be produced. So here's our question mark. And usually when we say how much calcium, we want to think about, well, when we say how much, what units are we looking for here? Well, calcium is a solid. What units would you usually use to measure a solid substance in chemistry? You would usually weigh it on a balance, electronic balance, and so you would have it in grams. And so we're going to look for grams here. And oftentimes it'll ask you how many grams of calcium are going to be present when this reaction is done. Now again, I know this is a limiting reactant problem because I have set amounts of the reactants of the sodium and the calcium nitrate. I have set amounts of those. So from here, I'm going to show you how we figure out how much calcium is present. You can use either method to figure this out. Both methods are about the same amount of work. And so I'm going to show you both ways. I'm going to do the same like I did last time. I'm going to start with the method where we go from each reactant to product, and then I'll go ahead and show you the other method as well. Okay, so if we start now, remember, what do we need to do first before we do anything else? We have to balance this reaction. So let's come over here. I have 2 nitrates on this side, so I know I need a 2 here. That gives me 2 sodiums, so I need a 2 over here. And normally we wouldn't put the 1s in here, but let's just go ahead and put those in so we can real clearly see those mole ratios. Okay. All right. Now, again, in order to figure out the limiting reactant, I want to know which of the reactants makes the least amount of product. And in this case, I'm asked for the calcium. So I'm going to go ahead and take both calcium. Side note, if the problem asks you for how much of both reactants is present, when you're determining a limiting reactant, you can just pick one of the products to go to. It doesn't really matter which one. You're going to end up having to go to both products in the end, but you have to figure out the limiting reactant in this process. And so we do 2 problems to figure out which one is the limiting, and then we use that limiting reactant to go to the other reactant as well. That was a lot in one sentence there. So we'll see that as we go here. So the first problem I'm going to do is take 75 grams of the sodium, and I'll figure out how many grams of calcium produced from the sodium. And then I'll take the 95 grams of calcium nitrate, and I'll figure out how many grams of calcium is made from that. We'll do those 2 problems. Okay. So this is only more complicated, more steps, because we're not going from moles to moles. We're going from grams to grams. And so this is going to be a 3-step problem instead of a 1-step problem like we saw over here, right? Because we need to get to moles, then use the mole ratio for each one of these problems, and then go back to grams. All right, so let's go ahead and set this up. I'm going to start and do the first problem. Okay, 75 grams of the sodium. Okay, and I'll abbreviate some of these units just for time's sake. So, and I'm also going to round my molar masses. I've already got those written down. I'm going to round them to the ones place, but normally you should round them to a few more digits, a few decimal places to give you a little more accuracy. So I know that 23 grams of sodium is 1 mole, right? Molar mass to the mole. Okay. Then I'm going to use the mole ratio. So I know that 2 moles of sodium will produce 1 mole of calcium. So 2 moles of sodium will produce 1 mole of calcium. Right? And then our last step, we want to get to grams over here. So I need a molar mass of calcium. I'm going to say 1 mole of calcium is, of course, from the periodic table, always equal to about 40 grams. Okay. So we punch that into the calculator, and we get 75 times 40, okay, divided by, and put that in parentheses, 23 times 2, so that we make sure we do order of operations correctly on this, and we get 65 grams. So I'm going to put that here. So and again, I'm being real sloppy with sig figs and stuff here, guys. I'm not focusing on all of that stuff, just for the sake of making sure we understand how to do this. So from 75 grams of sodium, I can make 65 grams of calcium. What about how much calcium can I make from the calcium nitrate here? So we gotta do another problem. All right, so 95 grams. And I'm just going to put C in for this, for calcium nitrate, okay? So I'm going to be good with our units, but for time's sake, I'm going to make it a little bit sloppy, be a little lazy here. All right, same process. We need to go from grams to moles, and I've got my molar mass here is 164 grams per 1 mole, okay? And then I know, and this is of this calcium nitrate, so I know from the mole ratio up here, right, 1 mole of calcium nitrate will form 1 mole of calcium. So that's the mole ratio, 1 to 1. Now we can go ahead and put in our molar mass of calcium, just like we did up here, right? 1 mole of calcium is 40 grams of calcium. So with this problem, when we punch it in, okay, we got 95 times the 40, and then we divide that by 164. And we get 23. Again, I'm being sloppy with my numbers here, but 23 grams of the calcium from that. So remember, the limiting reactant is the one that makes the least amount of the product. And when we compare these 2 numbers right here, which one makes the least amount? Okay, the calcium nitrate made the least amount of product. So that is our limiting reactant. So I'm going to write that here. Okay, calcium nitrate is our limiting reactant. And then we know also that whatever our limiting reactant is, the rest of the reactants are going to be in excess. There's going to be extra of those. So I can put excess reactant and just label that. Okay. Now, when the question asks how much product is made, we've actually already solved that problem. We figured it out. It's right here. We know that in this reaction, we are only going to make, oops, let's see, I'm changing my colors. I get a little sloppy on all this stuff. We know that we're only going to make 23 grams of the calcium. Why are we not going to make 65? We don't have enough of the calcium nitrate, right, to make 65 grams. That's like hypothetically, if we had a ton of calcium nitrate, 75 grams of sodium would make 65 grams of calcium, but we don't have enough of this, okay, to make that much. So because this is our limiting reactant, we're only going to be able to make 23 grams. This number is no good. Always, always, always. Like I always cross that number off so we don't accidentally use it for something else because it's really useless. The only purpose in figuring out that number is to figure out which one is the limiting reactant. Okay, so now we've got our number. We know how much this is going to make. Now let me show you. Okay, let me show you how we would do it the other way. So I got kind of a mess here. Let me erase a little bit of stuff here. The other method we're going to pick, now we already know which is the limiting and which is the excess, right? We already know which one is the hysteresis. That was 95 grams. Okay, 95 grams. And that was 75 grams. Okay, how do we figure out the other method? It's really the same amount of work. In terms of like stoichiometry and the math involved, we're going to do about the same amount. So we'll start, let's just pick one of the reactants. And since this one's first, I'm going to pick that one to start with. And I'm going to go from the 75 grams of sodium, okay, how many grams of the calcium nitrate would I need to react with the 75 grams of sodium? Again, we are going to, this number right here, the 95 grams, we're going to ignore that right now. We just want to know if we have 75 grams of sodium, how much calcium nitrate do we need to react with that? So we're going to go 75 grams of the sodium. We're going to do stoichiometry all the way to grams because we need to compare. We've got grams here, so we need to get grams here so we can compare those amounts, right? So 75 grams of sodium. Take that, so 20, let's see here, 23 grams per 1 mole of sodium. Okay. And now we're going to use that mole ratio. It's 2 to 1. So 2 to 1, 2 moles of sodium will react with 1 mole, and I'm going to abbreviate again, of calcium nitrate. Okay. Be careful with your abbreviations. It's only to save time here. It's really a good idea to write the whole thing. I know it takes more time, but it will keep your work organized and help you not make mistakes. All right. Now, last step, we need to get to grams. So I know that 1 mole of calcium nitrate in my molar mass was 164 grams. Okay. So that is, in this problem here, we'll go ahead and calculate this. We do 75 times 164. So 75 times 164. Enter, we'll divide that by 23 times 2. Okay, and we get 267. Again, I'm rounding here, not paying attention to sig figs. 267. Does that seem right? I think that's right. Okay. 267 grams of the calcium nitrate. So if we write that in here, okay, I'll give myself a little, 267 grams. If we reacted 75 grams, all 75 grams of sodium, we would need 267 grams of the calcium nitrate, but we only have 95 grams. So because we would need more calcium nitrate to react with the sodium, we know that the calcium nitrate is our limiting reactant. Okay. So really this method involves two steps. The first one is going from one reactant to the other and then comparing those numbers to figure out which one's the limiting reactant. Now, remember, the real question was how much calcium are we actually going to produce? That was the question we're trying to ask. So now the next step here is to take the limiting reactant and do another stoichiometry problem. Now that we know that this is our limiting reactant, now we're going to forget about this number. This is of no value to us. Its only purpose was to figure out which one the limiting reactant was. Right? Seems like a lot of work for that. And we're going to go from the limiting reactant, the 95 grams, to grams of product. So really the idea here is once we figure out the limiting reactant, that's the value that we're going to use to figure out how much of each product is made. And then we haven't talked about yet, but how to get the excess that's left over, which we'll talk about in a second. Okay, so here's what we do next. 95 grams of the limiting reactant. Okay, then we're going to use our molar mass here, which is 164 grams per 1 mole. And this is the calcium nitrate. Okay. And we're going from here to here. So we're going to use the mole ratio 1 to 1. And I'm going to get sloppy on my units here. And then I know 1 mole of calcium has a mass of 40 grams. Okay. So let's clean that up a little bit. When we calculate that, 95 times 40, right? 95 times 40 divided by 164. And we get 164. Nope, we don't. Sometimes my calculator does not like me very much. Let me try it again. Didn't make sense. It's always good to not just write numbers down, but to think critically about the numbers you get, because sometimes they're wrong. Oh yeah, that looks a little better. 23 grams, which look at, that's what we got up here, right? So both methods, which gives us a good indication we did things right here, says we get 23 grams of calcium from the limiting reactant. Okay. Again, you can see both of the methods we just used is about the same amount of work. It really just comes down to like, what do you feel more comfortable? Like, which way do you feel more comfortable doing the calculations? I'll also say it's almost a little bit easier if you calculate the amount of moles of each reactant you have and just use that to go to moles. And just work in moles until you figure out which one's a limiting, and then use the limiting reactant moles to figure out, grams of product and that kind of thing. So lots of different strategies, lots of different ways that you can do these problems. These are just a couple of the techniques you might use. Okay, last type of problem on here. How much of the excess reactant would be left over? Actually, real quick, let's say that it asked us for both amounts, like how many grams of this is made. We would start with the limiting reactant and we would go here. Okay, you cannot use the excess reactant mass for really anything to determine products. You have to take the limiting reactant, any number that came from the limiting reactant, whether it's grams of limiting reactant or moles, or even moles of the other product that was made, but you have to use one of those numbers that came from the limiting reactant to find out the other numbers we're looking for here. So we can do stoichiometry from the limiting reactant to figure out how many grams of the other reactant was left. We cannot use the excess reactant mass because we can't make that much of the product. We don't have enough of the limiting reactant to do that. All right, I just wanted to side note, I kind of got ahead of myself there. I thought about that as I was looking at this problem, because oftentimes you're going to see how much of each product is made, not just calcium, but what about both products? How much are we going to make of both of those? So you have to do stoichiometry from the limiting reactant to both of those to figure out which one or how much of each one is made. Okay, last problem. How do we figure out leftovers? Okay, well, there's always a question about how much is left over? How much of the excess reactant is going to be left, right? So really, since we already know this is the sodium is our excess reactant, how do we figure out how much is remaining when the reaction's done? Well, what we do know is that we're going to use up all 95 grams of this, and we're going to use some of the 75 grams, right? This is how much we start with, 75 grams of sodium. We're going to use some amount of that sodium. And if we subtract those numbers, let me do that in black here. If we subtract those two, this is going to be how much is left over remaining in the reaction. So how do we figure out this number right here? We're going to take our limiting reactant number, the 95 grams, or if you converted that to moles, we can go for moles. And we're going to go to here, grams of the excess reactant. All right. So again, stoichiometry to go from the limiting reactant to the excess reactant here. So let's go ahead and do that. Now it's important to note, whatever units you have here, that's the units you need to have for how much you use. Whatever units you start with is what you need to be subtracting. For example, we can't just go to moles here of the reactant, of the excess reactant, and then subtract grams from moles. That doesn't work. We need to subtract grams from grams. And if we are in liters at STP, for example, maybe we had oxygen gas at STP, we need to go to liters at STP so that we can subtract those two numbers. So just make sure your units are the same. All right, last problem here. So let's go ahead and take the 95 grams of limiting reactant, and I'm going to abbreviate it CN, and we're going to go to grams of sodium here. So I already know. And also, if you are really on board with this and you did the second method, the final limiting reactant, you actually would already have some idea of how much would be left over. But that's getting kind of complicated, and most students have a hard time making that connection. So let's see here. We got 95 grams of the calcium nitrate and 164 grams per 1 mole of calcium nitrate. Mole ratio is 1 to 2. 1 to 2. 1 mole of the calcium nitrate will react with 2 moles of sodium. All right. Last step, we know that every 1 mole of sodium has a mass of, where'd it go? 23 grams. One tip when you're doing these problems, just calculate all your molar masses and jot them down somewhere. In fact, calculate them twice so you don't make a mistake, because you're going to be coming back. You notice how many times we just used all these different molar masses. Calculate them, and then just have them handy, kind of have a little cheat sheet, or write them above each of the substances in the reaction, whatever. And it'll save you, some headaches of going back and trying to find it and all that kind of stuff. So let's punch this in the calculator. 95 times 2 times 23, and then divided by, let's see if my calculator works here, 164. Okay. And that gives us 26. Again, I'm rounding. That's okay. We'll round it to 27 because it's 26. So 27 grams. So I just figured out that I'm going to use 27 grams of then sodium when I react the 95 grams of the limiting reactant. So we just need to subtract that now. We need to subtract what we started with minus what we used based on the limiting reactant, and we're going to get about 48 grams is going to be left over. That's how much is going to be left. So recap, when you're trying to find leftovers, start with your limiting reactant amount, do stoichiometry to the excess reactant to find out how many grams or how many liters of STP, whatever units you're starting with, go to that. And if it's moles, then just go to moles. That's a little bit shorter too, but usually it's grams or liters of STP. Then don't forget to subtract. You got to subtract those to get your final answer here. Okay. All right. There are other methods to determining the excess and limiting reactants in problems, but these are the two that students usually understand the most. And so those are the ones I wanted to show you. This takes practice, and the more you practice and really think about what you're doing, the better you get and the more you understand these problems. Okay. So good luck. Please ask questions and have fun with it. I know it's chemistry. It seems like it's not fun, but it is. It's a good time. All right, guys. Thanks for listening. Have a wonderful day and school.